Think about the last thing you ate. You know exactly what it tasted like, but do you know what it did inside your body 20 minutes later? We experience the side effects of our meals all the time without realizing the connection. That heavy wave of fatigue hitting you right at 3 p.m., a sudden breakout of acne, or a thick layer of brain fog that makes it impossible to focus on a simple email. For most of us, human biology operates like a black box. We control the inputs by putting food in our mouths, and we feel the outputs through those physical symptoms. But the actual mechanism connecting the two remains totally invisible to us. When those outputs are negative, society has a habit of blaming the user. We are constantly told that we lack willpower, or that our symptoms are simply the result of eating too many calories. We even blame our own genetics. But as researchers at DNA testing companies have found out, genetics are better at predicting your probability of developing a disease decades from now. Your DNA does not dictate whether you wake up feeling energized or exhausted tomorrow morning. If our genes and calorie counts do not explain our daily physical and mental state, there has to be another variable at play, a hidden metric operating in real time that we are failing to measure. That metric is glucose. It is the primary source of energy for our cells, and it was originally engineered millions of years ago by plants. Through photosynthesis, a simple sprout performs an incredible chemical trick. It pulls carbon dioxide from the air and water from the soil, using the energy of the sun to fuse them together into solid matter. The result of that fusion is glucose. As this schematic shows, the leaf acts as a tiny factory, taking in water and carbon dioxide to produce oxygen and sugar. That sugar becomes the energetic foundation for almost all life on Earth. But a plant cannot rely on the sun shining 24 hours a day, so it needs a way to store that energy for later. Because loose glucose molecules tend to dissolve chaotically, the plant deploys enzymes to link them together into stable, connected geometric branches. We call this stored form starch. Plants also package glucose into other structures. They link it end-to-end to create rigid fiber for their trunks and stems, or they convert it into an extra sweet version called fructose, packing it into fruit to tempt animals into eating and dispersing their hidden seeds. This system worked efficiently until human diets intervened. Modern food processing mechanically strips away that protective fiber. Instead of eating a whole plant, we extract and consume the starch and sugar in highly concentrated, unnatural doses. By digesting this highly purified biological supply chain, we overwhelm our body's ability to process it smoothly. We are overloading our modern metabolic system. Continuous glucose monitors provide the first high-resolution view of these internal reactions. For the first time, people without diabetes can see exactly how their specific lifestyle choices impact their blood chemistry in the moment. Look at this graph. Traditional finger prick tests only give us those isolated white circles, a few random snapshots a day. But the sweeping line of a CGM reveals the extreme peaks and valleys occurring continuously between those points. This chart shows exactly what happens when you drink a glass of orange juice stripped of its natural fiber. You see a glucose spike. It is a steep bell curve where blood sugar concentration rapidly surges above the baseline and then violently crashes back down. That violent crash is the physical trigger for the symptoms we discussed earlier. That sudden afternoon fatigue, the intense cravings, and the debilitating brain fog are the direct physiological aftermath of a steep drop in blood sugar. Health outcome depends on the velocity of absorption. A calorie that hits the bloodstream in 10 minutes creates a different biological profile than one that takes 2 hours. If your glucose levels are constantly spiking and crashing, the consequences reach into your long-term cellular health. Chronically dysregulated glucose leads to systemic degradation, contributing to the development of insulin resistance, heart disease, and conditions like PCOS. The common reaction is to overcorrect by adopting extreme restrictive diets, but poorly planned restriction is an equal hazard. A keto diet consisting entirely of cheese, or a vegan diet built on processed pasta, can severely disrupt your hormonal system and leave you malnourished. We have to stop looking at food in a biological vacuum. A high-sugar oatmeal cookie looks great when placed above a can of soda on the health scale, but it ranks far below a handful of almonds. Biological impact is entirely relative. The solution is to change the sequence of your meal. By eating fibrous vegetables first, you build a viscous mesh in the small intestine. This physical barrier slows down the subsequent absorption of starches and sugars, acting as a buffer that prevents glucose from flooding your circulation all at once. When you blunt that impact, the internal alarms shut off. You achieve a stabilized metabolic system. The result is steady energy that lasts all day, clearer skin, and the total elimination of those sudden cognitive crashes. You do not have to remain a blind passenger on a turbulent flight. By understanding how to read your body's data and taking steps to flatten your glucose curve, you sit up front, operating as the pilot of your own biology.